Welcome. I'm here today to talk about securing critical infrastructure. A couple of things. First of all, what is it? Second of all, what is the threat that's facing us there? I'm going to go through a case study, and then talk about where do we start, which I think is the important thing for all of us in this room. We're not listening to the talk for fun. I assume that you have something that you're interested in securing. So what is it? Critical infrastructure, if you are in any of these categories, you are critical infrastructure. It means that you have a system that is required for daily living. It gets people from point A to point B, maybe. It's responsible for keeping them healthy, for hygiene, for protecting them. For any of these reasons, you are actually playing a critical role in national security. And the threat facing critical infrastructure is different from the threat facing maybe retail or just a standard IT shop, a legal office. It's different because I think for anyone else, this is the scariest thing to see. Nobody wants to see this. This is an IT nightmare. This is a ransomware notice. All your files have been encrypted. This is, of course, an issue for critical infrastructure. It's not the worst thing facing critical infrastructure. I think this is where most people's nightmares stop. If you have a system that is in any of the categories, the previous categories, though, this is an issue for you, but it gets worse. So I want to talk about an Israeli water treatment facility. This attack happened in 2020. This treatment facility, I assume the Israelis are pretty good at security, and even they missed something really important here. They had an HMI, they had a human-machine interface system, which means that this is a computer. A human operates the computer. On the back end, though, it's talking to physical infrastructure. They had an HMI that was exposed to the internet. So you could have seen this had you looked on Shodan, which I hope you all know what Shodan is. I think it's a critical part of any security org. You should be checking Shodan. It should be telling you if there are internet-exposed assets that shouldn't be. A mail server or a web server you would expect, that's supposed to be hit by somebody from the internet. That's its purpose. If it's anything else, it should not be exposed to the internet, and yet they are all the time. So that should be a regular check for your organization. Do I have anything that's internet-facing that shouldn't be? We find it all the time. In this case, it was a bad one, so it's an HMI. This HMI is communicating to programmable logic controllers, communicating to PLCs. These PLCs were responsible for controlling the temperature of the water, for controlling the amount of chlorine in the water. So you can imagine if this water is being delivered to a population, they're drinking it, it has the risk of poisoning them. So sure, ransomware is bad. If you have critical infrastructure, there are other things to worry about too. Second thing that they failed at here was that HMI system didn't require any authentication. And this is more common also than you would like to think. They don't change the credentials in the system. Nobody checks it for 20 years. And if you have a critical infrastructure system, especially for things like water treatment or in energy, a lot of those devices have been online for decades in some cases. And who's checking them? Who's checking things like this? A lot of the times, these kinds of devices, these non-standard devices, they're not going through the same vulnerability gap assessment that the standard managed compute is. And part of that, and I'll get to this more in a bit, but part of that is people don't know what to do with them. You have the people in the plant who understand these devices, and then you have the IT people. They're not the same people. Third thing that was an issue here, legacy system. Again, really common in critical infrastructure. It's critical infrastructure, so they're not going through upgrade cycles like you would in a standard patching process for an IT system that's doing billing, right? I mean, that's fine, take it down for a weekend, patch it, great. For things like this, though, they tend to fall out of that cycle, and the downtime is a risk in itself. So because of resistance to downtime, because of risk to plant operations, they don't end up on the same upgrade cycle. They're often very old. And I'll talk about this final point more in a bit, but attackers, in this case, understood PLCs. They got into the system, they were able to issue commands to the PLC to read, to write, to make it do something. They understood what they were doing with those devices. Does your SOC team, does your security team know what to do if they see, even if they could see it, right? Let's say that they can see the communication back and forth to a PLC. Do they have any idea what's expected? My guess is probably not. So where do you start? An anecdote. My first job in college, my engineering internship, was for a nuclear power plant, this nuclear power plant. And what they did was they hired 6 interns to just go through blueprint after blueprint of devices in the plant and check and see if they were in the computer system. If they weren't, they had to go talk to the plant engineer and add them to the system so that they could get maintenance, be upgraded, get on some kind of a schedule. It took me 10 years to realize I was a human asset discovery agent, and I was updating a CMDB. But what they were doing was smart. So they weren't just looking at devices on the network, right? They were looking at every device that was critical to plant operations. So I'm guessing most of you have a CMDB that's filled with computers, right? It's got your endpoints in it, it's got your servers in it for sure. And it's probably not exactly up to date or accurate, but it's got most of what's present in the network there. What I'm guessing you don't have is any record of where the HMIs are, where your SCADA systems are, which PLCs are online. I'm guessing that your building management systems are handled by facilities people, and they're not considered part of the network itself. We all remember the unlucky retailer that got breached through their HVAC system. I mean, the attackers are looking at these devices. We need to be looking at these devices too. Other things that are online, when I see client networks, there are industrial robotic arms. They have IP addresses. They're communicating. What are they talking to? Do we have any idea? Monitoring systems, safety monitoring systems. There was a Saudi Arabian petrochemical plant that got attacked, and they attacked specifically the monitoring system so that they could tell, well, so that they would no longer be able to tell if the values that they were showing, indicating the health of the plant, were accurate or not. Those are a big target, as are IP cameras. I think there was maybe some of you are aware of the Hikvision cameras. The US Department of Defense issued a notice about them. They said that they were compromised devices. If you look at the traffic from those IP cameras, they're not just communicating for updates. They're doing other things. So do you know where the IP cameras are? If an issue like that if a notice like that is issued, do you know where they are to replace them? I think even responding to notices like this is difficult. We have no idea where these devices reside. And there are some other obvious ones here, right? I mean, if you have a plant and that plant is using chemicals in any way, there are hardware controllers. Those hardware controllers are online. Those are vulnerable. This is a really good example of a vulnerability for a non-standard device. And these devices, PLCs, programmable logic controllers, they are in every system that considers itself critical infrastructure. You've got PLCs on the network. These PLCs are vulnerable, and it's worse than vulnerable. I doubt most security teams know how to update them. If there's a patch released, does your team know what to do if they're supposed to update a PLC? I think most don't. That's not a failure, it's just a reality of security. Most teams don't know what to do with that information. But this one in particular was a bad one, and there are similar, by the way, I'm not picking on Schneider, there are similar CVEs for other vendors as well. But this one in particular was discovered by my company, so of course I'm going to talk about this one. And in fact, it allows a remote takeover. The person who takes over the PLC can even set it on fire. And the engineer in me wishes I was in the lab when they figured that out. I'm sure we literally burned through a few PLCs in this research. But this can happen in your plant. Those PLCs are not just in manufacturing lines. Those PLCs are controlling security doors, as an example. They're all over the place. They're all over your network. Do you know where they are? So the problem doesn't stop when you have the inventory. And I think discovery and inventory of what's on your network is critical. But it doesn't stop there. That's just the technology piece. Then there's a process and a people piece of this as well. So most companies, let's not even get into special devices or non-standard devices, most companies can't respond to the vulnerabilities that they know about right now. In fact, I talked to a major enterprise, and I'll tell you their method for dealing with CVEs. They have a ranking system. It's not just the CVSS score. It's slightly more interesting than that. But they have a ranking system, and they put them in a list, and they take the top 25, and they draw a line under the 25th one, and nothing below that is ever remediated. And this is not uncommon. Like, this is the process that most companies are facing. So we are in a state where we can't even manage the vulnerabilities for regular devices, for the things that we're currently monitoring and aware of. There's a really poor understanding or ability to prioritize. You have a limited team, you don't have an unlimited security budget, you're not going to be able to monitor or fix everything, you just can't. So there's got to be a better way to prioritize than drawing a line under the 25th. I mean, I don't even blame them for doing this. I think they don't have the tools to do it differently. But I would offer that the device context, knowing what's on your network, having device context, it gives you a way to prioritize better. So I care if there's an endpoint that is infected with malware. I care much more if it's my domain controller that's infected with malware. So understanding what the device is and what its purpose is critical. Any devices that control physical hardware should be prioritized. HMIs, SCADA systems, PLCs, you have to pay attention to them. They need to be monitored. You need to understand the traffic, and that's the key piece. You have to understand what's expected of these devices. And critically, anything that's old, and again, critical infrastructure has a big problem with this. There's legacy everywhere. Anything that's old, anything that's not covered by existing tooling, the HMI probably doesn't have an endpoint agent. It just doesn't. So what's the plan for devices that don't have any protection? And I'll say, in addition to prioritizing by device, prioritize by the egregious gaps. I see these all the time in networks. Sure, we can get really fancy with security and think about nation-state threats and what are we going to do for some complex attack. I don't even think that worrying about the complex attack is important if you don't have table stakes security. And often there isn't table stakes security. And I'll give you a few examples from things I've actually seen. You would be shocked by the number of environments that have dark web traffic or actual Tor nodes in them. Security has no idea. Devices that are establishing connections to external devices with control protocols. I mean, this is foundational security. Nothing like that should be happening in your network. These devices are communicating with command and control sites at times. Systems, again, I'll talk about Shodan. You should be checking Shodan. Systems that are exposed to the internet that shouldn't be are top of the list. Figure out what's exposed. Should it be exposed? If it's not, remediate it right away. So it's not just about the CVE. It's not just about looking at a list of vulnerabilities. It's about understanding where in your network you have problems with things that are the ABCs of keeping an environment secure. But that's a process problem, tech problem. We talked about those. There's also a people problem. I don't think most organizations, let's say that they solved the tech, they have visibility into everything. I don't think most organizations know what to do with it. If your SOC analyst gets an alert for, it'll go back to PLCs, gets an alert for a PLC, let's say that the Israeli water treatment facility had a SOC team that got full visibility into the commands sent to PLCs. Do they have any idea what to do with it? Typically, that information is in silos. You've got the IT people, you have the OT people, or you have the medical people, or you have the people that specialize in the systems themselves, and then you have very IT-focused, managed device-focused people that are making up the SOC. And that's not true. In some companies have gotten a handle on this. Some companies have a very integrated security team. That is not the norm. So I think as an organization, it's important to ask, what will you do from a people perspective here? What kind of training are you going to give your SOC team? How will your SOC team know, again, let's say they've got the technology, we worked that out, how will they know who to call when they get an alert for a device that's a critical system, but it's at a site on the other side of the world? They don't have any remote remediation capabilities. Who do they call? Do they understand who owns it? There's an ownership problem in critical infrastructure. We are fighting the mindset that we've been in for decades, where, again, you've got people that manage the system, that own the system, and you have people that own security, and they're separate. So as we think about converging, there's all this talk about convergence in the network, right? Converging the medical and IT, converging OT or ICS and IT. That convergence also needs to happen in people. It needs to happen in training. It needs to happen in the mindset of the organization, not just in technology. And so the final point I want to make is that when clients get breached, most of the time, they're operating in silos. They're ashamed of it. They don't want to publicize it. It's a brand hit. It's a reputational problem. And maybe it's not something that they have to report. So they don't say anything. So instead, what I see are security teams operating in complete silos from one another. That is not how attackers behave. Attackers are not siloed. Attackers learn from each other, and they get better. So I think as an industry, my final point here, especially when it comes to a relatively new space of security for critical infrastructure, is that we need to be talking to each other more. We have to learn from each other. If we're not talking about these things, if we're not sharing information, if we're not getting better against attackers by learning from mistakes and successes of others, then we've already lost. So talk to your peers. I would urge you, learn from your peers. Start talking about what they're doing with their people, what they're doing to learn about these devices, what they're doing from a tooling perspective to get insight into the areas where they lack visibility, what they're doing to learn what's on their network. Thank you.